Hi, Cody. Thanks for sending the work in. Just a couple of small things. You did a nice job on this homework, by the way. Just a couple of quick things I want to go over with you. So here is 7.6 Reteaching with Practice, which is the one you did. And here on number 1, they give you these two triangles. And they're asking you, is it a reduction or an enlargement? And so you have to look at the letters. So the JKL that don't have the little tick marks next to it, that is like your original triangle. That's the first triangle. And then the one with the little tick marks is like your second triangle. They call that K and K prime. And so you have to ask yourself, when I'm going from this triangle to this triangle, is it getting bigger or is it getting smaller? If it's getting bigger, it's an enlargement. If it's getting smaller, it's a reduction. So if you take a look here on your work, you said JKL is smaller, which is true, it is smaller, but that's really not what the question is asking you. It's asking you when you go from this one to this one, whoops, sorry. When you go from this one to this one, is it getting bigger or smaller? And it's getting bigger, so it's an enlargement. On this one here, you can see this one is the original because it doesn't have the little prime numbers on it. So this is the original, and this is the second one. So once again, it's getting bigger, so it's an enlargement. On number 3, this is the original, the one with the little tick marks, the one with all the little primes is the second one. So when you go from the big one to the second one, or from this one to the second one, it's getting smaller, so it's a reduction. So make sure you understand what they mean by reduction and enlargement. And number 4 and 5 is a similar one to that. Let me find that. All right, so here's number 4. So again, you kind of have to look at which is the original and which is the second one. So it says find the scale factor of the dilation. So you're going from the big one to the small one. And when you're doing those, when you're finding the scale factor, your scale factor, to find the scale factor, you always put the new one over the original. That's kind of like your definition of scale factor, is new to original. So if you're trying to find your scale factor new to original, you have to say in this picture, well, the new one is this here, it's the little one. So that would be 14. So you're going to put 14. And the original is the big one, so that's 32. So 14 over 32. But don't forget that you want to reduce this fraction. And once again, I know you've got a button on your calculator that will do that really nicely for you. Either that or you can just go ahead and do it in your head. You immediately know that they're divisible by 2 because they're both even. So 14 divided by 2 would be 7. 32 divided by 2 would be 16. So your scale factor would be 7/16. Now, if it's getting smaller, this fraction has to be less than 1, which it is. So you can see, you can kind of check that. It is getting smaller because it's a dilation. So your scale factor has to be less than 1. Same thing on this one here now. The original is this one here. And the new one is this one here. So now it's getting bigger. It's an enlargement. So you're going to go new. Remember, it's always new over original. So on this second one here on number 5, the new is the one that has the prime on it. So that would be 19. And the original is 10. So that would be your scale factor, and you can't reduce that. And you notice that this fraction is bigger than 1, which makes sense because if it's getting larger. And if it's getting larger, then your scale factor has to be bigger than 1. And these two on the bottom, number 6 and 7, you did a beautiful job on that. Those are both 100% correct, and you showed your work really nicely. So good job on that. Let me know if you have any questions.